Welcome viewers, in this video we will see the non-weighted binary code. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. Link is given in the description box. Now we will go to the topic non-weighted binary code. In binary code there are 6 types available: weighted binary code, non-weighted binary code, reflective code, sequential code, alphanumeric code, error detecting and error correcting code. In this video we will see the non-weighted binary code. Non-weighted mean the each and every position there is no specific weight. For example, see here. So this is the weighted binary code 8421, 2 bar 1 bar, right? So each and every position having specific weightage is given. But this XS3 and gray code is coming under non-weighted binary code. There is no specific weightage, right? So first we will see what is XS3. What is XS3? So this is a decimal number given from 0 to 9. So each digit is excess by 3 digits, 3 numbers. So 0 is added with 3. 1 is added with 3, it become 4. So each and every digit is added by 3, so that called a excess 3. Each and every digit is excess by 3. So that 0 plus 3, 3. 1 plus 3, 4. 2 plus 3, 5. 3 plus 3, 6. 4 plus 3, 7. 5 plus 3, 8. 6 plus 3, 9, 7 plus 3, 10, 8 plus 3, 11, 9 plus 3, 12. For this excess code only we need to frame the binary code at decimal, right? So this is the decimal number, this is excess. By adding 3 we got new value. For this new value we need to frame the binary code. So it is following 8421 pattern, right? So first digit is 8, second digit 4, third digit 2, fourth digit will be 1. So according to the weightage we need to frame the coding. For 0 means it is 3. How will you get 3? Making third and fourth position as 1. So that 2 plus 1, 3. So that 0, 0, 1, 1. Third and fourth position 1 means 2 plus 1, 3. For decimal number 1, the excess is 4. How will you get 4? We'll make the second position as 1. So that second position will get 4. So 0, 1, 0, 0. Then for decimal number 2, the excess is 5. How will you get 5? We can add 4 plus 1. Second position and fourth position. So second and fourth position is 1. So that 4 plus 1, 5. The code is 0, 1, 0, 1. Then for decimal number 3, the excess is 6. How will you get 6? 4 plus 2. Second and third position we can make it as 1. So that 4 plus 2, 6. So that the code is 0, 1, 1, 0. Then for decimal number 4, the excess is 7. How will you get 7? We will make it as second, third, fourth position as 1. So that 4 plus 2, 6, 6 plus 1, 7. So the code is 0, 1, 1, 1. Then for decimal number 5, the excess is 8. How will you get 8? We will make it as first position as 1. So that we will get the 8 value. Remaining are 0, 1, 0, 0, 0. Then for decimal number 6, the excess is 9. How will you get 9? We can make it as first and last digit. So that 8 plus 1, 9, right? So 1, 0, 0, 1. Then for decimal number 7, the excess is 10. How will you get 10? We'll make first and third position. 8 plus 2, 10. So that 1, 0, 1, 0. First and third position is 1. So that 1, 0, 1, 0. For decimal number 8, the excess is 11. How will you get 11? We can make first, third and fourth. So that 8 plus 2, 10. 10 plus 1, 11. Right? So that 1, 1, 1. So 1, 0, 1, 1. That is a code for 11. Then how will you get 12? For a decimal number 9, the excess is 12. How will you get 12? We can make these two. 8 plus 4, 12. We can make first and second digit as 1. So that 8 plus 4, 12. Remaining 0. So the code is 1, 1, 0, 0. So in non-weighted binary code, the first type is XS3. We framed the code for all the decimal number 0 to 9 with the excess of 3. That is from 3 to 12. Now we'll go to the second type, gray code. Gray code also coming under non-weighted binary code. Now we'll see the details of gray code. Gray code is a non-weighted code and it is special case of unit distance code. So it is coming under non-weighted. What is the important thing in the gray code? In unit distance code, the bit pattern for two consecutive number differ in only one bit. Only one bit position will be differ. right? Not more than one bit will be differ, that will be useful for transmitting the data. The changing the circuit position from 0 to 1 and 1 to 0, it is very useful because only one bit will be changes, other bits are remain same. That is called a unit distance code, called a gray code. It's a special type. There is no specific weightage. There is no specific pattern available in the gray code. The only advantage what we have, it differ only, the consecutive numbers differ only in one bit. It also called a cyclic code. We will see what is cyclic code, right? So it is reflected. It is a cyclic code. We will see what is cyclic code while framing the codings. Now we'll go to the gray code, right? So the gray code is formed for the from 0 to 15. From the number 0 to 15, the gray code is formed. We will see these codes one by one, right? So this is a decimal number 0 to 15. So this is a building gray code. It's a final code. So what is the advantage here? So each and every digit differ by only one bit. So the 0 means 0, 1 means 1, 2 means 1 1. See this, only this 0 become 1, right? So for 0 it is 0 mean all digits are 0. For 1 only the last position is 1 means 0 0 0 1. For 2 1 1. So this position is make it as 1. What is the code? 0 0 1 1. See this, here 1 is available as it is, only this 0 is converted into 1, right? So there is a change in only one position. For 3 we will make it as 1 0, that is this 1 is make it as 0. The code is 0 0 1 0. What is the difference? Here 1 is changed to 0, all other codes are remain same. For 4 1 1 0, the code is 0 1 1 0. Here the 0 is changed into 1, the remaining codes are as it is, only one change, this 0 become 1. For 5 the code is 1 1 1, right? There is no specific weightage available here, right? So that is coming under non weightage. So 0 1 1 1, what is the change here? Only this bit is changed to 1, remainings are as it is, right? Only one change. For 6 it is 1 0 1, the code is 0 1 0 1. What is that? This 1 is changed to 0, other codes are, other positions are as it is. 7 1 0 0, so that 0 1 0 0, there is a final code. What is the change here? This 0 is converted, this 1 is changed to 0, all other digits are as it is. For 8 1 1 0 0, right? The final code is 1 1 0 0. What is the change here? Only this 0 is changed to 1, remainings are as it is, only one position, change in only one position. Then how will you get 9 1 1 0 1, right? 1 1 0 1. What is the change here? This 0 is changed to 1, other positions are as it is. That is the main advantage of the gray code. The consecutive number differ in only one digit. The 10 means all are 1, right? All 1 1 1 1, only this 0 is changed to 1, right? Then we'll go to the 11. 11 means 1 1 1 0, right? 1. So only this 1 is changed to 0. 12 1 0 1 0, there is no specific weightage. We need to remember this code. For XS3 code or a weighted code, automatically we can frame the codes from the weightage, but here there is no weightage is available. We need to remember the codes, right? So for 11 it is 1 1 1 0, there is only this is changed. For 12 1 0 1 0, right? 1 0 1 0 means this 1 is changed to 0, remaining as it is. 13 means 1 0 1 1, right? 1 0 1 1. What is the change here? This 0 is changed to 1, right? Then 14 1 0 0 1, this 1 0 0 1, this 1 is changed to 0. Then 15 1 0 0 0, right? 1 0 0 means this 1 is changed to 0, right? See this, all are changing by only one bit. It will be very useful for transmitting the data, changing the position. While changing the position, only one changes are there, right? So that is the advantage of the gray code. There is no specific weightage. This gray code is framed based on the advantage change in only one bit, right? And it is also called as a cyclic code. What is cyclic code? See this, we will see the cyclic code. See this 7 and 8. See this 7 and 8. 7 is 0 1 0 0. Here 1 1 0 0. Only one change. Similarly, this 9 and 6. This 9 is 1101, 6 is 0101, only one change in the position. Then 10 and 5, the 10 is 1111, the 5 is 0111, only change in only one position. Then 11 and 4, the 11 is 1110, the 4 is 0110, so change in only one position, this position is 1. Then similarly 12 and 3, 12 is nothing but 1010, 3 is 0010, only change in one position. Then 13 and 2, right, 13 is 1011, 2 is 0011, only change in one position. Then 14 and 1, 14 is 1001, but 1 is 0001, only change in one position. 15 and 0, 15 is 1000, 0 is all are zeros, so there is a only change in only one bit, right, remaining these three are 0, here also 0, here also 0. That is the advantage of the gray code, right. So in this video we discuss about the non-weighted binary code, two types, XS3 code and gray code. XS3 means for a normal decimal number we need to add 3, for every digit we need 3, for a 3 added 3 we need to frame the gray code from the using the weightage 828421. Similarly gray code means the two consecutive numbers differ only in only one bit, there is no specific weightage, we need to remember this code. The main advantage is there is a change in only one bit position, and also it is called as a cyclic, so this is a cyclic manner, cyclic code. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive, the link is given in the description box. Thank you for listening.